All right, so we're going to get into triangles. This is unit 4. We're done with unit 3. That was the last one we had. There were only 9 lessons in unit 3. So actually, I'd have to go all the way back up. So if I were to go back up to the table of contents and see what we got, there's, let's see, 3, 6, 10, about 10 lessons. And we probably won't get through this entire thing, okay? Again, we probably won't get through the whole thing. Depending on how next week goes, next week is gonna be kind of a tough prediction, just because, again, what I mentioned earlier with the announcements that they want, it might be an older document that they gave us, but it said that grades are due by the 30th, which is Wednesday, so I don't know if we're supposed to have everything wrapped up by then. So just be kind of prepared for anything next week. All right, so now we're moving into triangles. That's what this whole unit is about, is proving triangles congruent or not. But before we do that, we need to learn a couple of things about triangles. So first off, there are 2 ways to classify triangles. The first way is by their angle. So classify by angle. And then the other way is to classify by sides. So what are the sides doing and what are the angles doing, basically? All right, so here are the 3, well, actually 4. This one has 3, that one has 4. So here are the 4 possible ways that we can classify a triangle by their angles. So the first one is an acute triangle. So for an acute triangle, now this one's a little bit tricky because it says here all 3 sides must be acute. And they are. All 3 sides are less than 90 degrees. And if they are, then that's an acute triangle. Now, this is confusing because I remember a long time ago, I had a student, I think it was in a college course of mine, that said, that looked at a triangle and you know, they were looking at something like this and they said, oh, that's acute. And I'm like, what do you mean? Well, it's got 2 acute angles and only 1 obtuse angle. And I had to kind of remind him that it is 1 obtuse angle. You only need 1. And I sat there and I thought for a minute, how do you get 2 obtuse angles in a triangle? Okay, so you only need 1. That's the moral of that story. You only need 1 obtuse angle to be classified as a obtuse triangle. All right, so next thing here is right angle. So a right triangle has 1 right angle. That's what they call it. Okay, so if you ever need advice, you should always listen to a triangle with a 90 degree, all right, because they're right triangles. All right, and again, you only need 1. You don't need 2 or anything like that, just 1. And this one's another one that's kind of a different one because it's got 3 of them, just like the other one, but it would need to have 3 congruent angles. That means 3 angles that are all the same size. And we call this an equiangular triangle, which is kind of a new thing, actually. This morning, I don't think I've ever heard that, but I am normally, you know, for the past 6 years, I've been an Algebra 2 teacher, not a geometry teacher. I'm just sort of being pushed into this role. So a couple of things may have changed since the last time I taught geometry, which if I remember was like 2017, 2016 even. It was definitely a long time ago. But even then it was only like for 1 semester, and I'm probably in the same spot that I was kind of like where I am now. But I don't ever remember equiangular triangles being a thing. Anyway, so let's go ahead and look at this diagram that we have down here. So we're going to classify each of the triangles in that diagram. So we also, remember, we name triangles by their endpoints, the segment endpoints. So if I'm talking about any of these, you just have to follow the letters that it names. The symbol for triangle, well, that's pretty easy. It's just a triangle. So in this case here, problem number 1 is saying triangle CDE. So we just have to trace that, CDE. So they're talking about this triangle right here. And again, I'm tracing it just so that way you can easily see which one it is. And I know there's a lot of stuff going on here. Just try to ignore that. Okay, just try to ignore the rest of it and just focus on here. So CDE. And it has a right angle in there, so that would make it a right triangle. And then the next one here we have is BCE. So go from B, C, E. So they're talking about this one here. So looking at it, well, what kind of angles does it have? Well, it has an acute angle, another acute angle, but again, you only need one obtuse angle, all right? So I'm just joking here, but it's not, it doesn't mean all of them are obtuse, it just means one of them is obtuse. So yeah, BCE is an obtuse triangle. Move on to the next one. Old Honest Abe triangle, or at least that's what I'm going to call it, ABE. So here's the triangle, and this would be an equiangular, and you can tell because they mark the angles with those little arches that tell you that these three are the same angle, which is most likely going to be 60 degrees. So, because remember, they all have to add up to 180, the interior angles. Okay, I'm getting a little bit ahead of myself. But hopefully, with this whole summer class being a review, that rings a bell for you. All right, moving on to the next one, BDE. B, and then D, E. Now this one's kind of a weird one because the point of the triangle is downwards, and what we would normally consider the base is on the top. Or maybe it's kind of an angle that's really slanty. Okay, but anyway, BDE, so that's this triangle. Well, it has an obtuse angle. In fact, we can see a 90 degree right there, and it's wider than that. So it's wider than 90 degrees, so that would make it an obtuse triangle. And last one, CFE, so triangle CFE, CFE. And that's this little one right here. And it's got to be acute because we know that that one's less than 90 degrees. This one looks like it's less than 90 degrees, and that one looks like it's less than 90 degrees. So all three of the sides would be less than 90 degrees. So there we go. We got that one classified. Now we're going to go ahead and move on to classifying them by how their sides are. And remember, the word triangle means three angles, like tri, tri means three things, like a tricycle has 3 wheels, a bicycle only has 2 wheels. A tripod, if you ever try to stabilize a camera, you might use a tripod. And in that case, a tripod has 3 legs. Well, that's kind of what it means. Like pod means leg, like cephalopod. All right. So, let's go ahead and start working on how the sides relate to the triangle. So here I have 3 sides that are the same. So 3 congruent sides. So if you have 3 congruent sides, we call that an equilateral triangle. And looking at the equiangular, you might have thought, okay, well, if that's equal, one's talking about the sides, the other's talking about the angles. Lateral means side. So I'm sure you might have heard that before, the word lateral, but it means side or sideways. I'm trying to think of a word that has it, but it's kind of hard to think of one besides quadrilateral or something like that. I'm trying to think of something that's not math. But yeah, it just means equal sides triangle. And then since we only have 3 sides, well, what if we have 2 of them? So 2 congruent sides, 2 of them that are the same. So we would call that an isosceles triangle. And this one's kind of a weird word because it kind of comes out of nowhere. There are some words that have the word here, like isometric exercises or isometric dots or isometric drawing. But they don't really quite mean the exact same thing. So isosceles is kind of a weird word. So you're just gonna have to kind of remember that it's, this one you're gonna have to actually remember the definition. And if you ever get lost or whatever, and you need to answer this kind of question on a test or something, and you don't know what to do, right? You're lost on what to do next. You're probably just gonna have to figure out the other 2 and remember that this is the one that is the weird one that has 2 sides and doesn't really make a lot of sense. What about no congruent sides? Well, I can't say no one congruent side because it would go 3, 2, 1, but you can't have one congruent side because that just wouldn't work. What would it be? You can't have something be congruent to itself. So we call this a scalene triangle. And scalene doesn't really, well, it kind of makes you sound, it kind of, I don't know. To me, when I think of the word scalene, I think of something gross, like a scaly fish, right? Or scaly skin, or lime scale, like in a bathroom or on a sink. So kind of like, it kind of makes me feel like it sounds weird, right? So if something's weird, like this triangle, then it's scalene. It has no sides that match. And again, that's not a really good definition, but it's the best one I could think of like right now. So we're gonna do the same thing with this one here. Looking at the diagram, well, we have some marks that show that some of these are congruent. So these ones each have one mark, so they would all be congruent to each other. This one has 2 marks here and 2 marks there, so that means that it has 2 sides that are the same. All right, so let's get to it. So triangle JKM, so JKM. So JKM, that's the big triangle on the outside, and it's kind of hard to tell what it is. Maybe that's a right angle, maybe it's not, but it's very close to a right angle. And I can see that this side is longer than the top side. So if I were to kind of imagine it shifting over, K would be a little bit smaller. So these two, the top and the bottom side, are not the same, they're not congruent. And this side JK is obviously much smaller, so that tells me that this is likely going to be a scalene triangle. Let's move to the next one, KLN. So KLN. And again, trace the triangle, make sure you know which one you're talking about. If there's lines that go into the figure you're looking at, then just ignore them, you know, do your best to ignore them. And sometimes it might help to use like a colored pencil or a highlighter or something, but then that also gets confusing too, because then you know, you're going to be looking at ones from the last exercise. So it's usually best to just sort of trace it. So KLN is an isosceles triangle because those marks, the pair of marks there, tells you that these 2 sides are the same size. And if you have 2 that are the same size, remember that's an isosceles triangle. And that's the one that kind of really doesn't make sense, you know, thinking about it. Equilateral is pretty easy. In fact, the next one here, JKN, is an equilateral. Okay, that it just looks nice. It just has all 3 sides the same. All right, what we would normally call a regular polygon, because all 3 sides are the same side, or however many sides in a polygon you have. When they're all the same, that means it's a regular polygon. But that's, you know, equilateral, all 3 sides the same, easy to remember. All right, so now we're going to kind of name some triangles, and I think there's another exercise directly below this one. So we're going to go ahead and cover these and at the same time. And sometimes when you have these like split examples, like you know, this and this are the same thing. So what we're going to do is we're going to name them by the angle and by their sides. So by angle and sides. So the first thing we're going to do is look at the angle on the first one here. So number 9. Okay, so what clue do we have? We have a box, and that means that this would have a 90-degree angle in it. So it's 90 degrees, that means it is a right triangle. Now we need to look at the sides. So looking at the sides, it looks like we have a pair of matching sides. And remember, that one's isosceles. Kind of hard to remember that one. Sometimes like it's kind of a long stretch, but like I was talking about words that have isosceles in them, and that would be isometric exercises, and that would be something like jumping jacks, right? So in jumping jacks, you throw out your arms and legs, but your arms and legs don't change the sides, right? Your right arm is usually the same length as your left arm, and the same is true with your legs. So, you know, your arms and legs are the same, so you have 2 sides or 2 arms that are the same size. I don't know, that's, again, kind of a stretch, but I guess if it helps, it helps. I don't know if it actually helps. All right, next one, number 10. So here again, they give us another clue with what the angle is going to be. It says right there that it's 114 degrees. That's obviously larger than 90 degrees, so that would mean that this is an obtuse triangle. And it's kind of hard to tell because it looks like the bottom base might be the same as the right side, but if it was, then they would have little marks on it like they did with number 9. Since there are no little marks, we might assume that one of these is just slightly longer than the other. So if it's just slightly longer, that means that two sides do not match. So this is going to be a scalene triangle. All right, and then last one for this one here. So we have equilateral and equiangular. So looking at the angles, they're all 60 degrees and all the sides are 7 centimeters long. So equilateral and equiangular. Now, I kind of use an older textbook, and when I usually do cover geometry, it's usually not that much. But typically when you see something like this, we simply call it an equilateral triangle. Okay, because equilateral also means equiangular, because no matter how you have, if I have 3 sticks, so just imagine 3 sticks or 3 pencils, and they're all the exact same size, well, no matter how I join them end on end, they are always going to become equiangular as well. So a lot of times if you just say equilateral, people know what you're talking about. All right, so let's move on to number 12. Now this one tells us nothing about the angles. Okay, it tells us nothing about the angle. So looking at the diagram, well, that looks like it, well, no, it's not a right angle, because if it was, there'd be a little box right there. But you can also look really, really closely and see that it's a little bit less. It's probably like 85 degrees or something like that. Very close to 90, but not exactly a 90-degree angle. And if it was, again, you can see in the other example, they give you right angles. So this one doesn't have it, so it's very safe to assume that it is going to be an acute triangle, because it's always good to check all 3 sides and make sure all of them are less than 90 degrees. And the next thing would be to measure the sides. Now in this case here, it might look like these two are the same, but this one is just slightly shorter. Being slightly shorter, that means they don't have any 2 of the same sides that would match, right? So they're different sizes, all 3 of them. So that would be the scalene triangle. Okay, on to number 13 here. So right angle, scalene. So right angle right there. And usually with a right angle, unless you have 2 sides that are kind of the same like this, it's usually going to be a scalene. So right and scalene, because if I were to swing this side here, it would be slightly shorter than the top side. All right, so let me go ahead and move over to number 14. And in this case here, let's start with the angle. And you can see that this one says 97 degrees. So it's very close to 90. In fact, it's over 90. And remember, if it has even one angle that is over 90 degrees, then it is an obtuse triangle. Isosceles, because these 2 sides are both 5 feet. So they would match. Okay, they match because we know their number and they're both 5 feet. So that would mean that they are congruent. Okay, I'm gonna go ahead and move down a little bit. And I'm gonna just peek ahead really quick, 1, 2. So there's actually 2 more pages ahead of this too. So I'm gonna give you some time to cover this. And with this one down here, copy as much as you can. But with this bottom part down here, I've decided with my first hour that I was gonna kind of skip it. We're gonna kind of show another way of doing this. It's kind of a shortcut method, but it's not really like a whole lot shorter. So if you're watching this on a computer, then you already have what I'm gonna show you that you need to use it with. So anyway, I'm gonna go ahead and give you about 2 more minutes on this one. I spent a little bit of time on there, so. Oh boy. So it looks like we're gonna have to do the same thing, classify the triangles using this diagram here. And again, we use the endpoints of each section. Segment, that's the word. Okay. And with this one down here, this one, the reason, I'll get there when I get there actually. I'll just leave it to you. Okay, that's about 1 minute down. Okay, about 30 more seconds. Okay, and like I said, don't worry about getting everything on the classifying triangles part. That one's a little bit different, and then I might even just skip those actually. I might just leave them out of the assignment. Well, no, I can't do that because I already told my first hour I wasn't going to do that. So it wouldn't be fair for me to make them do it and then, you know, tell you guys not to do it. All right, so let's go ahead and talk about some of these triangles that we have up here. So the stuff that it gives us, so you were able to see everything, just making sure nothing's cut off. So PR, so where is PR? So that's this large line here. All right, so from point P to point R, that segment bisects SRT, so SRT. So that's this angle right here. Now, since we know it is bisecting that line, we know that if this is 30 degrees, this will also be 30 degrees because that's the definition of a bisector. So just like that pizza, right? If these two things were pizza slices and we managed to cut the angle right in the middle, well, that means both sides would be the same measure. So if that's 30 degrees, then this is 30 degrees. Let's see what else we can take out of this statement here. So U is the midpoint of RT. U is the midpoint. So this line here is the midpoint of R and T. So that would mean that if it's the midpoint, remember midpoint is kind of the same thing. That means that if this is 8 meters, the other side would also be 8 meters. So we can fill that in, put a little line there and point out that it is also 8 meters. Because again, that's the definition of a midpoint. Classify each triangle by its sides and angles, or angles and sides actually. So let's go ahead and look at the first one. Number 15 is UQR. UQR. So that's this one right here. So if we look at it, we can see that the angle is over it's over 90 degrees, but it is 120 degrees. So that would mean that this is an obtuse triangle. It also has two matching sides, right? Because this is 8 and that's 8 because, well, you can see because of these marks that they're both 8 meters. And since they're both 8 meters, that would mean that they are isosceles, so obtuse isosceles. All right, next one, RST. RST. So this triangle right here, well, let's see what we can get from it. So angle 60 degrees, 60 degrees. Okay, well, hold on, wait a minute. How many degrees is this? Now, by triangles definition of interior angles, you might remember that they equal up to 180. So if I add these together, it'd be 120. Then I'd have to subtract that from 180 to get how much is here. But there's also another way too. We could also use angle addition postulate, which is one of the things that we covered, like, I don't know, last week and the week before. And that is you can add these two angles together, right? So 30, 30, that would be 60. So 60, 60, 60. So this is an equal angular triangle. We could also prove this again. Let's say we didn't have one of these right here, the 60 degrees. Let's say one or both of them were missing. Well, this is 16 meter. This is 8 and 8, which would also be 16 meter, which is segment addition postulate, which says if I add these two together, then that would be the total length of S to T, which would be 16. Now, one of the other things we did was I think the word is extrapolated, but I also want to say conjecture. One of the other things we did, and that is something that we got because this 8m wasn't there. We got that from the statement and using definitions. So 8 plus 8 would be 16. So 16, 16, 16. So this is not only equal angular, but it is also equilateral. But again, I don't know of any distinction between the two of them or why you would need to make them. But since it says equal angular and equilateral, I'm going to go ahead and just go with both of them. Okay, number 17, SRQ. So SRQ. So they're talking about this one right here. And you can see that there's a right angle right there. So this is obviously going to be a right triangle. And if we look at the sides, that's 8 meter, 16 meter. But what about this one here? Do we know how long this is? Well, we do have a right angle, and almost all the time when you have a right angle, if you were to take this angle and swing it here, it would be, you know, something like 14 or 13. Well, we could get it, but we don't really need that right now, okay? In fact, I don't think we've covered Pythagorean theorem yet. That might sound familiar to you, but we haven't covered that, so I'm not gonna explain. And we don't really need this bottom part here, the leg. When you have a right triangle, that's what they're called legs. But we can tell that this is gonna be shorter than this, which means they're not gonna have two matching sides that are the same. So that means it would be scalene. Okay, so let's go ahead and go here. So this next one would be P or T. So start from P, go to R, and then T. So we're talking about this big old triangle here. So let's look at the angles of this triangle. So we have 30 here. We don't know what this is, but we also know that this is going to be 60 degrees. Now, how could we tell the angles? Now, actually, I am pretty sure that this would be 60 degrees as well. And there's a couple of clues that we have. This is 16 meter. This is 16 meter. The bottom is 16 meter as well. This meets at a right angle, which would probably mean that this would also be 60 degrees. Okay, but we don't need to prove the whole thing. We just need to look at this angle and say, okay, well, it's definitely bigger than 90 degrees, which it is. So that would be obtuse. All right, so let's check the sides. 16 and 8 and 8 would be 16. So actually this would be isosceles because both sides are 16 meters long. All right, so it takes care of that one. Let's go to the next one, TQU. So TQU. So that's going to be this one right here. So we already know that this mark here is 8 meters. Luckily, again, we got that. We got that from earlier, and we started filling in a few things. Sometimes it helps to fill in a few things even before getting started. That way you're not going back and being like, oh, okay, well, what about this and that? And does that mean this or does it mean that? But we can tell that this is 8 meter, that's 8 meter, and this is 8 meter because again, this is the same as that. So we know it's an equilateral triangle, equilateral. Now, it's got to be equal angular because again, I can't think of any situation where you would have something that is equilateral and is not equal angular. And it would have to be a closed figure as well. That's one other thing about geometry is everything has to be closed. You can't have any holes or gaps in the figure. And in this case, our figure is a triangle, so I'm guessing it's going to be an equilateral. We also know that this is 60 degrees. And we could probably do a couple of other things to get this. Like for instance, we could go 180 minus 120, right? Because this is a linear pair here. If we use a linear pair, this has to add up to 180, and that would mean this number would have to be 60. So that would mean I'd have two angles of 60 degrees, and then using the interior angle of a triangle, that would also be 180. So all three of these would be 160. All right, so last one now. Let's get to this one here, right? Scalene, oops, I'm sorry, PQT. PQT. All right, so let's see. We have, let's look at our angle. Right here, you can see that these are vertical angles. Vertical angle postulate says that opposite angles across the intersection would be the same. So that means this is a right angle right here. Okay, not only is it a right angle, well, okay, so it's a right triangle, but is it scalene or is it something else? Well, I'm willing to bet this. Remember we looked at the triangle SRQ, or yeah, SRQ. I am willing to bet that this and this are exactly the same triangle. Because again, vertical angles, if we were to use alternate exterior angles postulate, this would also be 30 degrees as well. Alternate interiors would say that 60 on the other side here would also be 60, but we could also prove that these are parallel lines as well. But also this side is 8 meter, this side is 8 meter as well. The long side is 16. And it's a little bit early right now, but there's something called side angle side postulate, which would tell you that these two things are the same. All right, I'm gonna go ahead and go down to this next part here. And like I said, I'm not gonna spend a whole lot of time on this next part. In fact, when I'm grading this, I'm gonna be super lenient on this. Now, I know we have covered, what was this, distance formula. I know we've covered distance formula before, and with my morning class, actually, I wasn't sure if we covered it before or not, but I do remember the one on how we get this. So a square plus b square equals c square, and you don't need this right now. I'm just, because it doesn't tell you what the distance formula is, okay? Nowhere in this lesson does it say this is the distance formula, use it. So I'm telling you, reminding you how to get it. And it'll make sense too, because when I started doing this, I remembered, hey, wait a minute, I taught this before. So now I remember that we did go over this. So what I'd have to do is take the square root of both sides, and I would get a square plus b square equals c. Because again, these two cancel each other out. The square and the root are inverse operations, so they will undo each other. And since we're not talking about one thing, we're not talking about just A or side A, because if you remember the triangles here, if we're talking about like side, we can label them with the letters. But in this case here, we're naming these triangles with points. So like J to K, K to L, and L to J. So that's what they're doing here. They're lining up those three sides. Now, because we have points on a coordinate plane, remember these are X and Y axis, X and Y points on a coordinate plane. So since there's two of them, what I'm going to do is I am going to break this down. So A is actually going to be two numbers, and B is actually going to be two numbers as well. And here's how I remember we went over this here, because when you leave it blank, you're going to have to put in a minus in there. And I told you that this is like goat goggles, right? Because you got to put the eyeballs, the goggles, and then it's got to have the 2 on there. So it's kind of like drawing a goat, as I call them, goat goggles or a goat helmet. You can easily imagine that there's a goat in there. Actually, no, goats don't have that kind of nose. They have this kind of nose. But hopefully you can see it. And that's how I remember the distance formula. So anyway, it's the same thing. You're going to plug in your x here, x minus x, y minus y. And then you can also plug in 1, 2, 1, 2, and then just grab these here and plug them into there. So that's what they're doing. But like I said, I'm not going to go into all of that because this is quite a bit of work. And I don't want to throw too much work on you because I still want you to finish your packets kind of quickly. So what I'm going to do is, since you're watching this on a computer or any kind of internet device, I'm going to say, why don't we do this? Let's just go ahead and go to Desmos. And luckily I already have these up here. So I went ahead and put those points in here into a graph, and we would measure it. So I know it's kind of tough if you don't have a measuring device. And this is one of the reasons why they did the formula, is because looking at this, right, tilt your head a little bit, it looks like it might be an equilateral triangle. And this is what I mean by I am going to be lenient when grading this, because if you said equilateral on something like this, I'm probably going to go ahead and just accept it. But actually it would be an isosceles triangle, because if we look at the three sides, we have one side that is root 68 degrees, which I don't know. Actually, can I take that? 68 square root would be 8.2462112. Well, I'll just say 8.2. And then root of 72 is 8.4. So they're just 0.02 decimal difference. Or I'm sorry, 0.2 decimal difference. So that's like 1/5 of whatever unit they're talking about. That's a small difference. But if you did the whole thing using distance formula, you will notice that one of the sides is a little bit longer. So therefore it would not classify as an equilateral triangle. All right, but again, don't worry about doing all of this. If you copied it down, that's good. At least you'll have it. But yeah, I'm not gonna really require too much of that writing down. If you have the internet, just use Desmos. And as long as it's close enough, or maybe if you have like a graph that you drew, that'll work also. Okay, sorry, moving on. I spent a little bit more time. I'm not gonna go over those two again for the reasons I just got done saying. All right, so now we're gonna work on some of these algebraically. So what does that mean? So we have our triangle, and we're going to solving for triangles sides with algebra. Now let's see, what time did we start? Darn. Looking at the time, I might only be able to do one of these pages, but hopefully you get the idea from it. I think that same thing happened with my morning class too. I tried to get through it, but we had a morning fire drill this morning, and I was like this close to finishing the other one, but I think they pulled the alarm like 4 minutes early, or sorry, like 2 minutes early, and I was like 2 answers away, so I had to go wait for the whole thing to be over, then I had to start again. Okay, so with this one here, all right. Should I give some time to work on this, or should we just go straight into it? Because again, my time's running a little bit. Well, I guess we got like 10 more minutes, but I don't know. I might barely finish this in 10 minutes. I'll give you 1 minute to write this down. And even if you don't get all of it, again, we'll probably cover some of it later. And the writing is big enough so that way you can see everything here. So actually, in this case, I would say that if you're a pretty slow writer, you could probably start with 4 and 5. And then when we go over it all together, then we'll go over 1 through 3. Oh boy. Stretch, stretch. You know, actually, I've been sitting since 12:15. I don't think I even got up this whole time. Maybe I'll go get I don't have any more snacks. I don't have any more water either. Darn. No, maybe I'll just maybe I'll just walk around. Maybe I'll walk to the end of the room and back. Oh, I do got water. Okay, that was probably a little bit more than I was expecting. All right, so let's go ahead and go over some of these. And again, if you had a good time management, you might have gotten all of them. So some of these are not really that, they're kind of straightforward. So let's look at this one here. ABC is an equilateral triangle. Solve for both x and y. Okay, so we have x and y, and then we have a third side that does not have any numbers. I'm sorry, variables. It is only a number. That's probably what I meant to say. I had a hiccup right at that moment too. Okay, let's see, 3x plus 1. Now they pick this side and the side that has the 49 on it because it's really easy to just set them equal to each other because it said that it's an equilateral triangle, which means all three sides would be the same length. So that would mean 3x plus 1 would also be the same as 49. So we're going to do that. We're going to set them equal to 49 minus 1 from both sides. 48 minus 1 is, I'm sorry, 49 minus 1 is 48. Divide both sides by 3, and you get 48 divided by 16. I'm sorry, 48. Okay, back up. 3 times what gives me 48? Well, I can divide both sides by 3, and that would give me 16. So I know that x is now 16. I've answered one of the questions. Put that in a box. All right, next one here. Since we still know what 49 is, we're going to go ahead and keep using that one. But we need to get y. So we're going to grab the side with the y, and we are going to go ahead and put it right there. So 18y minus 41. Now add 41 to both sides so that we get rid of it. And we have 90 right here. So 18 times what gives me 90? Well, that's easy, 5. So y is equal to 5. All right, so next one here, let's go on to number 2. So triangle RST, which is this triangle, is an equilateral triangle. Find x and the measure of each side. So we got to find the measure of each side. So we have 3 sides. RS, which they have right here, ST, which is right here, and then TR or RT. Usually it's best to just keep it in alphabetical order. So I know TR doesn't really make a lot of sense because, well, R goes first in alphabetical order. Now here's the thing, since it is an equilateral triangle, we would only need to find one side. So let's pick 2 sides and set them equal to each other. Now with this one, really, you could pick any 2 sides. These 2, those 2, these 2. But it looks like they went with these 2 here for this example. Set them equal to each other. Do basic algebra, right? So minus 7 from both sides because we got to pick a side for the variable to go on. 10 minus 7 is 3x. Now we also have add 6 to both sides. So adding 6, 18 plus 6 would be 24. And 3 times what gives me 24? Well, 8, right? I had to put 8 in there. So 8 would have to be what it would go in there. Now it doesn't say anything about oh, well, it actually does say find x right here. So that's the first part. But we also, again, need to find the measure of each side. So what we're going to do is we're going to take each of these sides, 12x minus 22, 12x minus 22, 10x minus 6 right here. And we're going to take out all of the x's and replace them with 8 because now we know that x is equal to 8. Plug each one in and evaluate each one so we get 74. Now realistically, you could have just said 74 on all of them because if it's an equilateral triangle, finding one means you know what all the rest are going to be. Okay, so I'm going to move on to number 3. So same thing, let's see, starting out the problem, triangle MNP. is an equilateral triangle. Find x and the measure of each side. So let's look at what we have. 4x minus 25, x plus 14, 6x minus 51. So I don't see anything wrong with this. They all have an x statement, whereas the first one had a y. Since they all have x, I can pick any two of them and set them equal to each other, which it looks like they picked the top two, 4x minus 25 and x plus 14. And I probably would have done that too, because 51 is a large number. And even though you would still get the same answer, you just have more numbers and larger numbers to work with, which is always bad. So anyway, let's do our regular algebra stuff. Minus 1x from both sides. 4x minus 1x is 3x. Add 25 to one side, to both sides. And if I have 14 plus 25, that would be 39. And 3 times what gives me 39? Well, okay, that would be 13. So now we have x is 13. We're going to plug them back into each side, and now we're going to get them. So in this case, that makes sense. All sides should be 27 because it tells us that it is an equilateral triangle. Whew. All right, so these next two are a little bit different. So I'll go ahead and cover these ones as well. So here we have triangle DEF, and it tells us that it is an isosceles triangle with segment DE, which is the left side, and EF, which is the right side, would be congruent. So that's the symbol for congruent. Find the measure of each side and x. All right, so in this case, we don't really have a big choice. We can't pick these two because those are not equal to each other. We cannot pick these two because they are not equal to each other. We only have one choice, and that is to set these two equal to each other. So 8x minus 13 and 5x plus 17, we're going to set them equal to each other because, again, isosceles means that they're congruent, and congruent kind of means that they are equal to each other. Minus 5x from both sides. 8 minus 5 would be 3x. I want to get rid of this negative 13, so I'm going to add 13 to both sides. 17 plus 13 would be 30. And if I ask you what is 3 times what gives me 30, that one would be pretty easy. You would immediately say 10. But now this one here, we have x right here, so it says find x. So actually, you know, there should be a box around that. I don't know why they didn't box that. Okay, but now that we have that, take this and plug it back into each of these here. So again, segment DE, that's this one right here. EF, which is the right side. DF, which is our bottom side, or the base as sometimes we call it. So that'd be 67, 67, 31 once we plug them in and evaluate them for each side. And we have another isosceles triangle here. So it tells us WX, which is the left side, and XY, which is the right side. Again, it tells us they are congruent, and we could mark these with little marks if it helps us, which it looks like they did. Now again, these two top sides are the only ones that are equal to each other. So if we set them equal to each other, we should be able to get x using basic algebra. Once we get our x value, we're going to plug them back into these over here, and that should give us how many, the length of each side. So now we know that WX, right, take 6x minus 77 and replace x with 27. So we substitute it in. When it's evaluated, we get 85. Same thing with XY and WY. All right, so that's it for this one here. We're out of time. We're about to be out of time in another few minutes, actually. So what I'm going to do is, for this one here, I'm going to go down to the next one, and I'm going to go ahead and let you just kind of get that on your own. I guess we could go over it. There's not really much that we could go over. It's very similar to the ones we just got done covering, right? So it says equilateral triangle. Some of these are isosceles triangles. And those are pretty much the only two you're going to be working with. Because if it's a scalene triangle, you'd have to know a lot more information. But anyway, in this case here, you're going to have to fill these parts in. So PQ, there's no drawing here, so you're going to have to fill that drawing in yourself. Label PQR as the corners of your triangle. PQ is 18 plus 1. QR is 24 minus 17. That's the second one. So it says it in the statement. PR is 15x plus 10. That's our bottom side. So from P to R. From here, you would basically take it over like we did with any of the last 5 that we did. So again, there is quite a bit of stuff to cover. So what I'm going to do is I'm going to give you the top part here. I'm going to zoom in just a little bit in case, again, I have to be considerate because some people might be watching this on a phone or a very small screen or a low resolution screen. So I'm going to go ahead and give this a couple minutes. I'm going to probably go with about 2 minutes in total. So I'm going to go 1 minute, then I'm going to go down, then I'm going to go another one. And I know that's not enough time, but I'm going to go ahead and use this time for the rest of it to be the independent student learning time that we set aside. Okay, and I know this is a little bit later than usual, but we started 5 minutes later because of the internet issues that I had before starting this class. So because of that internet issue, we got delayed a little bit, and it caused the whole thing to go on a little bit longer than we should have gone on for. So anyway, that will be it for now. Till today is Thursday. We have no school on Friday, so don't forget that, no school tomorrow, okay? So I don't need to get any messages of people logging on to Zoom, or so far it hasn't happened with summer school, but sometimes that happens. Like it'll be obviously a day there's no school, and then I'll get messages from my email or sometimes even my phone of people saying, hold on a minute, how come I'm in the Zoom but nobody's there? Okay. So yeah, be careful with that. All right, I'm gonna leave it here for another minute then. Like I said, we'll go into independent student learning. Let me go ahead and take attendance while I'm here. Remember, you have to be here for student independent learning. It's not optional. You gotta be here. It is considered to be part of the class. So actually, I noticed that I only have a few less students than I should. Should not be like that. So I'm gonna go ahead and take a screenshot for the attendance. For my own record. It's a lot easier to do attendance in my morning class because it's all just one time period. There's no separation of lunch. And the independent student learning time makes more sense because it's just one big time in the middle of the class. All right.